In this video, we will see further problems from exercise 3.4, question number 17. Prove that sine a plus b into sine a minus b is equal to sine squared a minus sine squared b. So let's solve the first one first. So the question is to prove sine a plus b into sine a minus b is equal to sine squared a minus sine squared b. So let's take LHS. That's equal to sine a plus b into sine a minus b. So let's apply the formula for sine a plus b. Sine a cos b plus cos a sine b, this is multiplied with sine a minus b, which is sine a cos b minus cos a sine b. So multiplying this is like a plus b into a minus b. So it will be a squared minus b squared. So it's sine squared a into cos squared b minus cos squared a into sine squared b. Now our solution is all in the sine form. So let's change all the cos into sine. So sine squared a into cos squared b is 1 minus sine squared b. 1 minus sine squared b minus, again cos squared a will be 1 minus sine squared a into sine squared b. Now let's multiply the terms which are outside and remove the brackets. So this becomes sine squared a into 1, which is sine squared a minus sine squared a into sine squared b minus 1 into sine squared b minus into minus plus sine squared a into sine squared b. Sine squared a, sine squared b. Now let's rearrange this. After cancelling these two terms, they are plus and minus. Your answer would be sine squared a minus sine squared b, which is equal to RHS. Hence the proof of the first problem. Question number 2. Cos of a plus b into cos of a minus b, this is to prove, is equal to cos squared a minus sine squared b, and it's also equal to cos squared b minus sine squared a. So let's take the left hand side. LHS will be equal to cos a plus b into cos a minus b, which is nothing but cos a cos b minus sine a sine b, the whole thing into cos a cos b plus sine a sine b. So this is again in the form a minus b into a plus b. So this will become cos squared a cos squared b minus sine squared a into sine squared b. Now let's change all the terms which are not here into terms which are here in this first part of the question. So we have cos squared a, so that's fine. We don't have cos squared b, so change that into sine squared b because we have that here. So this becomes cos squared a into 1 minus sine squared b minus, again sine squared a is not there, so change it into 1 minus cos squared a. Cos squared a is there into sine squared b is there, so this is sine squared b. Let's actually call this as 1. So this becomes cos squared A, multiplying this inside, minus cos squared A sine squared B minus sine squared B. Minus into minus becomes plus cos squared A sine squared B. Now these two terms can be cancelled, so your answer will be cos squared A minus sine squared B. Now this is first part of the problem. Okay, then let's rearrange this with 1 minus sine squared A minus again sine squared B into cos 1 minus cos squared B. So your answer here would be 1 minus sine squared A minus 1 plus into minus will be plus cos squared B. So your answer will be 1 and 1 will be cancelled. So you will be left with cos squared B minus sine squared A. So this is 3. Therefore, from 2 and 3, LHS is equal to RHS. Hence the proof. Question number 3. To prove sine squared A plus B minus sine squared A minus B is equal to sine 2A sine 2B. So let's take the left hand side first. So LHS is equal to sine squared A plus B minus sine squared A minus B. Now this is in the form sine A plus B minus sine A minus B multiplied by sine A plus B plus sine A minus B, which is A squared minus B squared is equal to A minus B into A plus B. So let's take each of the term and let's simplify for the expanded further. So sine A plus B would be sine A cos B plus cos A sine B minus sine A minus B would be sine A cos B. So since we have a minus here, so minus and minus will become plus cos A sine B. This is multiplied with the second term. Let's go for the second term. That would be same as this. Sine, only the sign would be changing. Sine A cos B plus cos A sine B plus sine A cos B minus cos A sine B. So here we can simplify. These two terms will disappear, and here these two terms will disappear. This is equal to, here this term would be 2 times of cos A sine B. So 2 times cos A sine B, and this term would be 2 times of cos sine A cos B. Sine A cos B. Now we can rearrange this as 2 times of cos A sine A into 2 times of cos B into sine B. Yeah, it's the same as cos A sine A plus cos A sine into cos B sin B plus cos B sin B. Now if you look at this is nothing but sine 2A and this is sine 2B. So which is equal to sine 2A. We know that sine 2A will be equal to sin A cos A plus again cos A sin A. And this is going to be similarly sine 2B, which is equal to RHS. Hence the proof. Question number 4. To prove cos 8 theta cos 2 theta is equal to cos squared 5 theta minus sin squared 3 theta. Now let's take the left hand side. Left hand side equal to, now you can see that 8 and 2 are here. On the right hand side we have 5 and 3. So 8 can be broken into 5 plus 3 and 2 can be 5 minus 3. So that's equal to cos of 5 theta plus 3 theta into cos of 5 theta minus 3 theta. Now this will be equal to cos squared 5 theta minus sin squared 3 theta, since cos of A plus B into cos of A minus B is equal to cos squared A minus sin squared B. So applying this formula here, we get this. So this is equal to our right hand side, hence the proof. Question number 18. Show that cos squared A plus cos squared B minus 2 cos A cos B cos A plus B is equal to sin squared A plus B. So let's take the left hand side here, which is equal to cos squared A plus cos squared B minus 2 times of cos A cos B into cos A plus B. Let's expand cos A plus B. So this will become cos squared A plus cos squared B minus 2 cos A cos B into cos A plus B is cos A cos B minus sin A sin B. So further multiplying this, you will get your answer as cos squared A plus cos squared B minus 2 times of cos A cos B into cos A cos B would be 2 times of cos squared A into cos squared B. Then minus into minus will become plus 2 times of cos A cos B sin A sin B. We can now rearrange this as cos squared A minus, let's take one of the cos squared A cos squared B here. So cos squared A cos squared B. We have minus 2 cos squared A cos squared B. So I'm taking one term here. Then let's put the plus cos squared B. Then let's put the second term here, minus cos squared A cos squared B plus our last term, which is 2 times cos A cos B sin A sin B. Now here we can take the cos squared A out because it's common. So cos squared A into 1 minus cos squared B plus, similarly here cos squared B is common. So cos squared B into 1 minus cos squared A plus 2 cos A, cos B, sin A, sin B. And that's equal to cos squared A, 1 minus cos squared B is sin squared B, plus cos squared B, 1 minus cos squared A is sin squared A, plus 2 times of cos A, cos B, sin A, sin B. This is now in the form of A squared plus B squared plus 2AB. So it's equal to cos A sin B plus cos B sin A, the whole square. So cos A sin B plus cos B sin A is the formula for sin A plus B. So this is equal to the whole square. So it is equal to sin squared of A plus B. That is equal to the RHS, hence the proof. Question number 19. If cos alpha minus beta plus cos beta minus gamma plus cos gamma minus alpha is equal to minus 3 by 2, then prove that cos alpha plus cos beta plus cos gamma is equal to sin alpha plus sin beta plus sin gamma equals to 0. So let's take the given equation. So given cos alpha minus beta plus cos beta minus gamma plus cos gamma minus alpha is equal to minus 3 by 2. So let's bring the 2 to the side. So this becomes 2 times cos alpha minus beta plus 2 times cos beta minus gamma plus 2 times cos gamma minus alpha. And let's bring the minus 3 this side. This becomes plus 3 is equal to 0. Now let's expand cos alpha minus beta. So 2 times cos alpha cos beta plus sin alpha sin beta plus again 2 outside cos beta cos gamma plus sin beta sin gamma close brackets plus 2 times cos gamma minus alpha will be cos gamma cos alpha minus sin gamma sin alpha plus the 3 we can rearrange it as plus sin squared alpha plus cos squared alpha, which is equal to 1. Let's repeat the same for beta and gamma. So then plus sin squared beta plus cos squared beta plus sin squared gamma plus cos squared gamma. This is equal to 0. So now we can rearrange this as moving all the cos terms together and sin terms together. This will become, so let's take the cos first. So cos squared alpha plus cos squared beta. So this is here. Then cos squared gamma cos squared gamma plus 2 times cos alpha cos beta, then plus 2 times cos beta cos gamma, then you have plus 2 times, this is a plus here, cos gamma cos alpha. Then let's take all the sine terms. So this is plus sine squared alpha, sine squared beta. Let's write them down first. Plus sine squared beta plus sine squared gamma plus 2 is outside, so it is 2 times of sine alpha sine beta plus 2 times of sine beta sine gamma plus 2 times of sine gamma sine alpha is equal to 0. Now if you see, this is nothing but a plus b plus c the whole square. This is a squared plus b squared plus c squared plus 2ab plus 2bc plus 2 ca. So this is nothing but a plus b plus c the whole square. So cos alpha plus cos beta plus cos gamma the whole squared plus similarly this will become sine alpha plus sine beta plus sine gamma to the whole square is equal to 0. Now you have two square terms and you have to add them up. The two square terms will always be positive, and if you add them you will get a positive number. So this condition is only possible for this term to be equal to 0 if this is equal to 0 and this is equal to 0. Therefore, cos alpha plus cos beta plus cos gamma is equal to 0 and sine alpha plus sine beta plus sine gamma is equal to 0. Hence the proof. Question number 20. Show that first one, which is tan 45 degrees plus a is equal to 1 plus tan a divided by 1 minus tan a. So let's prove the first one. Tan 45 degrees plus a, this is to prove, is equal to 1 plus tan a divided by 1 minus tan a. So let's take the left hand side, which is equal to tan 45 degrees plus a. So applying the formula of tan alpha plus beta, this becomes tan 45 degrees plus tan a divided by 1 minus tan 45 degrees into tan a. Substituting the value of tan 45 degrees, which is 1 plus tan a divided by 1 minus, again this is a 1, this becomes tan a. So which is our right hand side. Hence the proof of the first one. Now let's go to the second one, which is we have to prove tan 45 degrees minus a is equal to 1 minus tan a divided by 1 plus tan a. So let's take the left hand side. So LHS is equal to tan of 45 degrees minus a is equal to, applying the formula for tan alpha minus beta, you get this as tan 45 degrees minus tan a divided by 1 plus tan 45 degrees into tan a. Again, applying the values of tan 45 degrees, this is 1 minus tan A divided by, this is again 1, so it becomes 1 plus tan A, which is equal to our right hand side. Hence the proof. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.